Let us now study one of the illustration based on lens, and some questions are there along with the ray diagram. We have to study it very carefully. We have to draw the ray diagram and answer the following question. So I have got a lens L, a mirror, plane mirror M, and then I have a point object O, and I have some questions to solve. So first question reads, draw two rays from point O of the object to show the formation of image I at O itself. That means rays coming from the object O after refraction through lens, can I say, will get reflected, and when the rays get reflected they will again hit the lens and again will get refracted and will form some image. Now here it is given that object O and image I are located at same point. So that is nothing but retrace of path. That means I am talking about principle of reversibility of light, that when path of a ray of light is reversed, it retraces the path. So if we talk about retracing of a path from a mirror, then there is a condition I have explained you, that if on a mirror, if a ray has to retrace its path, then it must incident perpendicular on plane mirror, right? That means rays from O after refraction should hit perpendicular to plane mirror. So if I, let's say, consider two rays, this ray, and let's say it is hitting perpendicular to plane mirror, and this is the second ray, and again it is hitting perpendicular to mirror, right? Then we can say that if these rays are hitting perpendicular to mirror, then the rays will get reflected along the same path, and if the rays are traveling parallel, it will get reflected from the mirror and it is retracing its path. So definitely the image I, okay, will obtain at this point only. So the image I of the object O is located at the same point. It will be applicable only when the rays from the object, okay, after refraction through lens travels parallel to principal axis and incident normally on the mirror, so that it will retrace its path and will form the image of the object at O itself, right? That means for the image to form at object itself, the ray should retrace its path. So this is the first question we have completed. If I talk about the size of the image, okay, the image will be of same size because it is formed due to the rays getting retraced. So definitely the image will be formed of the same size. So what is the size of the image? If I am writing the answer for 2 over here, it will be same size. It is asked two characteristics of image. Now since the image is formed due to actual intersection, then definitely the image is a real image, and real image is always inverted. So these are the two characteristics of image. So we have completed 2 and 3. Now we have to name the distance of the object O from the optical center of the lens. That means they are talking about these distances. This distance. So from the definition, if any ray coming from an object after refraction through convex lens, if the rays are traveling parallel to principal axis, then definitely the rays are coming from the principal focus. So this object is located at the principal focus of lens, and this being the optical center. So this distance, right, this distance is called as, come on, tell me, focal length. For the fourth answer, the name the distance of object O from the optical center of a lens. So this distance is called as focal length. And if I talk about fifth question, to what point will the rays return if the mirror is moved away or towards the lens? That means this being the mirror, and if I shift the mirror behind, let's say if it is moved away from the lens, so it doesn't matter because the ray traveling parallel to principal axis will still hit perpendicular to it, so that the rays will get reflected or retraced along the same path. That means if the mirror is moved away from the lens, but remember the mirror should be perpendicular to principal axis. That means if the mirror is moved away from the lens, it doesn't matter, the rays will retrace its path, and if the mirror is moved towards the lens, so this is the point towards, this is moved away, it doesn't matter, ray will still retrace its path. So to what point the rays will return? The rays will return at point O itself, because the rays are still traveling parallel to principal axis. So even though the mirror is moved away or towards the lens, the rays are still traveling parallel to principal axis. They are still hitting perpendicular to mirror. So they will retrace along the same path, and by principle of reversibility of light, the image will form at O. That means the ray will meet at point O itself.